prime over 1 plus u squared. Since it's just x, u's just x, right? So we could just say that the derivative of this is 1 over 1 plus x squared. And this is where I'm worried you weren't here last semester to know all these rules. We might need to write those out for you at some point.
I thought that was the derivative of regular Q. No, just kidding, I didn't think that. I remember.
Because the derivative of tangent
It's not that.
secant
It's
squared.
like
Right, okay.
something else.
This one I did x ln of x, but that's just to remind you of how to take the derivative of ln and how to take the derivative of ln of u.
It's like u prime over u.
U prime over u, but this would be the product rule, right? So if I took the derivative of this, I would take the derivative of x, which is 1, times ln of x, plus x times the derivative of ln of x, which is 1 over x, or this would be ln of x plus 1. Just come back to you, right? What about e to the x? It's my favorite derivative, because what's the derivative of e to the x? E to the x. So this would be product rule, though, right? The derivative of that would be 1 times e to the x plus x times e to the x. So today we're going to look at integrating a few of these, and I just have some rules for you, and then we'll talk about maybe finding the area without using area formulas. If we get to that, we'll see. So I can't really hide any of this because I printed it out for you. But remember that the derivative of ln of x is 1 over x, right? So if I want to go backwards and I want to say, what's the integral of 1 over x, just so you know, if you try to do the power rule on this, what would this be? This would be like x to the negative 1, right? And how do we integrate this? Have we talked, remember, like we add 1 and then divide by that. What would happen if we added 1 to negative 1? And then we divide by 0? So here's my big hint to you. If you forget this at some point, that this is ln, when you try to do the power rule, you get that you're dividing by 0. So I hope that will be like a red flag that you're like, oh, that can't be right. I must be thinking something else. But remember that this is just the antiderivative. So what function has a derivative of 1 over x? It's ln of x plus c. And normally, we have to say ln of the absolute value of x because you can't take the ln of a negative number, so we'll come back to that later, but just know that sometimes absolute value is thrown in there. Okay? There's a lot of notes today, but there's like one thing on like 4 pages. I could have saved some paper here, but you know. So, look at this weird looking problem. It says, find the indefinite integral, the integral of 1 over x minus 5 dx. When you see something like this, you want to think about this new rule that I have. What if that was, I don't know, do I need to do a u substitution here, or do you see that like whatever's in the bottom could be what goes with ln? You follow me on that? Like I could say, what if u equals x minus 5? I could rewrite that as 1 over u, right? And if you can write it like that, then it's always going to be the value of that integral is going to be ln. You don't have to do this if you can kind of just recognize. But do you agree that if I change that to 1 over u, I would say that's ln of u plus c? Follow me at all on that? And then I can just plug that back in. So I could say the ln of x minus 5 plus c. And again, the reason that we put absolute value bars around that is because you can't take the ln of a negative number, and so you have to just make sure that whatever you put in there wouldn't be negative. What about e to the x? Did I give you one of these? Oh my gosh. Do you have one of these? Or are you writing everything down?
Yes.
Okay, I kind of forgot when you came in. I was worried. What do you think the integral of e to the x is? Yeah, because the derivative of e to the x is e to the x. And don't forget plus c.
Yeah, you definitely wasted it.
Eventually, we're gonna do harder things with this, some U substitution stuff, but today it's pretty straightforward because that's all we got. No, it's not. We're getting to harder stuff later. What about these? The inverse trig ones are awful, I just have to say. Oh, look at that. That's terrible, isn't it?
Yes. Like, so would it be better for us to just like memorize it? Like, is that what
Yeah. So it's kind of weird because it's really nice if a is 1, because a lot of times when we did it, it was like 1 minus x squared. But really, a could be anything. But what I want you to recognize is when you see stuff like this, at least recognizing right now, it's got to just fit one of these categories. But the reason I give you this is right here. Inverse tangent and ln are very easily confused with each other because inverse tangent doesn't have a square root. Inverse sine and inverse secant, and there's 3 other ones that aren't listed on here. I don't know why there's only 3 here. On the AP test, I can't say for sure, but I can tell you that in years past, the only one that's ever shown up is inverse tangent because people confuse it with ln, and so they put it as a multiple choice question, and one of the options is ln, and one of the options is inverse tangent, and they want to know if you know the difference between it. And so let me think of, I have an example on the next one, but like if I had the integral of 1 over x squared plus 1, a lot of people are going to think ln here, because they're like, oh, it's 1 over something. But there's an issue with that, because think about if you said, oh, it's ln. It's ln of x squared plus 1. What would the derivative of that be? What would the derivative of ln of x squared plus 1 be? 2x over x squared plus 1. So you see how that does not fit the ln pattern? Because you have to take the derivative of the inside, because there's an x squared there. And so when you see something like this, you just have to think about, is it ln or is it inverse tangent? And this would be inverse tangent because it's x squared plus a squared. And the answer to this would be, a is 1, I think the easy one, it'd just be 1 over 1. It would be inverse tangent of just x plus c, because it's just 1 in there.
So if it's x squared, then it's not that.
Right now. Not always. Well, it's going to get much more complicated after we have a chapter 5 test, but right now, for the most part, if it's x squared. Inverse sine, inverse secant, yes, they might show up in this book. They're not going to show up on a test for me because I've never seen it on the AP test, and I'm not going to make you, like, crazy memorize it. But I just want you to be aware that you could do it working backwards and the square root stuff. But this one is the real reason that I give you that. Okay? So, inverse tangent, ln kind of go together. So, look at the next one here before we get into the other stuff today. That is going to be inverse tangent because it matches the thing. So see if you can figure out what a is and see if you can write the answer to that integral before I do it. That's the formula. So you just, they can put x first, they can put a first, it doesn't really matter, but you just want to recognize that a is 3 in this one, and x is just x. And so you should be able to say that's 1 over a, so that would be 1/3 times inverse tangent of, I forget already, x over 3 plus 3, so it's x over a. Yes? Again, right, yes. You have to make sure that a is always a number, always. And so even if they mix them around, so even if, like if it was, I forget which way it's written in there, but you have to remember that x is always the variable and a is always the number. Okay, so yes, it's 3 over x is not the same as x over 3. Because you, the 1 over a, like that's where this comes from right derivative, you need that there in order for it to cancel out. But I really feel like I need to like make you a whole derivative review because you missed a lot last semester. But that's why. A is whatever's the number squared, so that's where the 3 is coming from. So since A is 3, it's 1 over A inverse tangent of x over A plus 3. And the first problem we did, A was 1, so you didn't have to put anything there. 1 over 1. All right. We'll come back to this a lot more, all right? This is just like kind of like baby steps today. But the real reason I'm giving you this is because the goal, if we can get through this today, is to talk about how can we find the exact area without using area formulas. So what if I asked you to find the exact area of this? I don't want rectangles, I don't want approximations, I don't want you using the button on your calculator. I want you to actually be able to use the calculus to give me the exact answer. And so I wish I didn't print this out for you because it lets you see everything at once and not let me like work a little bit at a time. But it says the derivative with respect to x of the integral of f from a to x is simply f. And we kind of talked about this. Derivatives and integrals like are inverses, they undo each other. So if we took the derivative of some function, we would say, they're saying from a to x, that it's actually just f of x, because the derivative kind of undoes the integral, sort of. It says this means that the integral is an antiderivative, and using this definition, we can conclude if you have some function bounded from a to x, it will always equal capital f of x minus f of a, capital F. And the capital F represents the antiderivative. So notice x and a are your bounds. Capital F is your antiderivative, which means for us to find exact area under a curve, we just have to do the antiderivative, which we've been doing, working backwards. But now instead of just doing plus c and getting this generic equation, we can actually plug in the bounds to say, okay, this was my original equation, I'm going from a to x, and you can actually find the area of those. So here we go, this is kind of the big deal of the day. Can't believe Sean's not here to argue with me about capital F's and lowercase f's. Let's do one with real problem, and then we'll see, let's do one, and then you let me know what questions that you have about it, okay? So, it says evaluate the integral using antiderivatives. If I asked you to find the area of sine of x from 0 to pi, we would have to use rectangles if we didn't have this thing that I just showed you, because it's a curve. We can't find a geometric formula. We could use RAM, but that's still just an approximation. So using this, I'm going to write this up here. The integral from a to x of f of t equals capital F of x minus capital F of a. Just to remind you why I'm doing this. Step 1 is you got to get what capital F is, and capital F is the antiderivative. So can you tell me what the antiderivative of sine of x is? Negative cosine? Yes? And what the notation for this is we say this equals negative cosine of x. No more plus c right now. No plus c when you have bounds here. Notice on the ones we did at the beginning there were no bounds. And how do we show we're evaluating it from 0 to pi? We draw a little line and we say from 0 to pi. No, the integral, right? The antiderivative. Right, like this is the derivative and you're going backwards. And then you're just going to plug in the top bound and subtract it from the bottom bound. So I'm going to say negative cosine of pi, watch your signs here, minus negative cosine of 0. That's my capital F x minus capital F of a. Take the top bound minus the bottom bound. Or upper bound or lower bound. And then you just work it out. What is the cosine of pi? Cosine is x, and it's -1, but there's a negative out front, so do you agree that that's just 1? I'm gonna go ahead and make that a positive. What's the cosine of 0? X coordinate at 0 is 1. So we can say, what? Oh my gosh. That it's 2, right? Don't leave, I'm holding hostage. So what about on this one if it wasn't a crazy one? How many more pages do I have? Maybe just one more. We can do this one and then we'll stop for the next one. I forgot my dx here. What would the antiderivative be, or evaluating the integral of 3x squared be? We haven't done this in a while, but what do we do with that?
Add 1 to the x cubed.
Yeah, power rule. So it's like 3x cubed, and then you divide by 3. Right? And then I'm going to say from negative 1 to 2. Cross my 3's out. Ready with me on where I'm getting those values from? And now I just plugged in. You have to remember, upper bound first minus lower bound. Otherwise, you're going to get the wrong answer here. And I'm just going to say that's 2 to the third minus negative 1 to the third. And what I'm actually finding here is the same thing as if I was using a geometric formula, if it was a geometric. I'm finding the area of that. And this is how we do it without rectangles. So this would be 8 minus negative 1 would be 9. So I had this one where we had to actually do some stuff with E, and maybe we'll, if you get to one on your homework tonight that you can't do, we'll work it out tomorrow. But this is what I want you to try to do for homework tonight. The plan is a worksheet tomorrow.